Dear students, welcome and thank you for tuning in. I'm going to present a couple of videos about 3-point bending, the experiment that we did in lab 5. We sent to you the data. I'd like to clarify some of the steps that you need to do in order to complete your report. So this is part of the mechanics of material lab and experiment number 5, which is 3-point bending. In your handout, you were asked to complete the following tasks. So you need to calculate the maximum elastic bending moment at the mid-span. You need to calculate the elastic flexural strength. This is the formula for it. You need to plot the force deflection diagram and find the slope in the linear region. P over D, which is F over D, actually the force over deflection. You need to calculate the elastic modulus of the specimen. So I'd like to go through this one by one and just to explain what you need to do and how you can do it. You were given the following information, that the deflection at the mid-span is force multiplied by the length cube divided by 48 elastic modulus multiplied by the moment of inertia. The moment of inertia for our rectangular specimen that we used, you can find this from textbooks or online. So it's B, which is the width, multiplied by H, which is the height of the, H is the thickness, which is the height. So it's the thickness of our specimen to the power 3 and divided by 12. So B is width. So in our specimen, you have length, width, and you have thickness. So you will use the width and thickness. According to this formula, you have the moment of inertia. The slope from the region portion of the load deflection diagram that you will be compiling and getting from the instrument machine when you do the 3-point bending test is the slope of the linear portion. And we will talk about this, how we're going to use it in our calculations. First, start with the step 1, the first step. To calculate the maximum elastic bending moment of the mid-span, remember we have 3-point bending. So schematically, we have our force at the mid-span, and then we have the, this is our specimen, the length of it, and you have F over 2 and F over 2. If you wanted to find the elastic bending moment, you will do the section method. So you will cut the specimen from here, and then you get this portion. If you want to do the analysis from statics, what will you do is that you have F over 2, you have L over 2, this is your length, and then when you do the sectioning, you will add the moment and you add the shear force, V. To calculate them, you should go back to your statics class. In order to have this at equilibrium, you would want to have the summation of forces equal to 0 on the x-axis, summation of forces equal to 0 on the y-axis, and summation of moment around the specific point should be equal to 0. And to eliminate everything, we use this point here. So summation of moment around this point should be equal to 0. If you did this, this is your m, assuming that clockwise to be positive. So this is minus m, and then you have this force here multiplied by L over 2, and it is positive, and you will end up by having m equals to the force over 2 multiplied by L over 2. And that's how you calculate your moment. To summarize, your moment will be F, the force at the mid-span, the maximum force, multiplied in the elastic region, multiplied by the length of the specimen, divided by 4. And you can go and check your calculations for doing that. One of the things that F is the force at the proportional limit of the curve. So if you have this curve for bending testing, the moment at which you will start leaving the linear portion, start curvature, that's your proportional limit from the curve, and L is the length of the specimen. So in order to calculate the moment, you need just to find the force from here, multiplied by the length of the specimen, divide by 4, and then you have your elastic moment. From the data that you were given, so this is how the force deflection curve would look like. Your proportional limit would be somewhere here. That's your proportional limit. So I use the force at this point to calculate the value that is here, which is 292.3 Newton meters. Make sure that you are converting the lengths from millimeters to meters in order to have it in Newton meter. In the next video, I will explain to you the second calculation that you need to calculate for this lab. Thank you for watching. Until the next video. Bye.